constant. We, the Department of MCA, believe in the same and incorporate the spirit of learning in our daily life. I am Pavitra, working as an assistant professor in the Department of MCA, MIT Mysore. A very good afternoon and warm welcome to all of you for the inaugural function of the 5-day faculty development program on Introduction to Python, organized by the Department of MCA, MIT Mysore. Now I request our HOD, Professor Manjunath B, to welcome the guests and participants.
Good afternoon to all. It is my privilege to welcome you all for this 5-day faculty development program on Introduction to Python, which is scheduled for from 20th December 2021 to 24th December 2021, and it will be conducted in online mode. I heartily welcome all the participants to this FDP. So first and foremost, I would like to follow the protocol by welcoming our Chief Patron, Dr. Murli S., President of MIT. Welcome you, sir. I would like to welcome our beloved Principal, Dr. Naresh Kumar BG, Principal, Maharaja Institute of Technology, Mysore. Welcome you, sir.
Yes, sir.
I would like to welcome the mentor of our department and Dean Administration, Dr. T. Vasudev, and also Secretary of MIT. Welcome to the FDP, sir. And I would like to welcome all the organizing committee members and advisory committee members and various heads of the departments, Dr. C. Ramakrishna, Professor and Head Civil Engineering, Professor and Head Mechanical Engineering, Dr. Sharad Kumar Bhai, Professor and Head ISC Engineering, Dr. Shivamurthy RC, Professor and Head CSE and Engineering, and Dr. Ravi Chandra, Professor and Head EC and Engineering. And I would like to welcome the participants who are registered for this FDP, who will be with us for next 5 days. I will be welcoming you all for this FDP wholeheartedly. Thank you all.
Thank you very much, sir. On behalf of organizing committee, I welcome you, sir. Now I request Professor Amos R to give a brief introduction about the FDP.
Good afternoon all to the dignitaries and adult faculties of various parts of India. A warm greeting from the Department of MCA of Maharaja Institute of Technology, Mysore. On behalf of the department, I take this privilege to introduce to our institution and the department. Maharaja Institute of Engineering and Technology, popularly known as MIT, is been situated in a beautiful, enhancing and revealing landscape about 4 kilometers from Columbia Asia Hospital. The institute was founded by a group of eminent people recognized for their eminence in the field of science and engineering technology. Many of them have served at the highest level of AICT and the university. The college is equipped with a modern learning aids to make teaching learning process a pleasure. A highly qualified teaching staff is its asset. Our college is accredited with NBA and the NAAC. Coming back to the department, it was established in the year 2008 and mentored by Dr. T. Vasudev, our mentor. The Department of MCA impacts training of the student to make them competent, motivated software professionals and technocrats. The department not only supports the freedom of thought, but also encourages growth, cultivates human values, and concern for the environment and the society. The department tops in the Mysore region under university-affiliated MCA college in terms of results as well as ranks. The important technological aspect that today is prevailing is the Python. The need of Python is an interpreter, interactive, object-oriented language. It incorporates modules, expectations, dynamic typing, and many other features. Python as a package has encapsulated different categories and functionalities in libraries. So in order to help our teaching community, we have organized this 5-day FDP as a part of knowledge sharing, in which sessions will be handled by eminent and experienced persons. We have participants from various parts of India like Karnataka, Nagpur, Udaipur, Aurangabad, Odisha, Vijayawada, Madanapalli, Chennai, and many more. So it's our pleasure to have you all for the 5-day FDP program. Thank you very much.
Thank you, sir, for the introduction. Now, I request our beloved principal, Dr. Naresh Kumar BG, to address the participants.
Good afternoon, everybody. I'm audible?
Yes, sir. Yes, sir.
Okay. So, Professor Manjunath, Team Coordinator, HOD of the MCA, Mentor of the MCA, Dr. Associativity, Chairman Murli, and other faculty members and expert lecturers for this 5-day introductory on Python programming. So, the name Python is a big one. So, similarly, the programming part, whatever you will learn, it will be learning in a big way. It will be useful for your career in the upcoming days because it is a faculty development program. So, I think all the faculties studied earlier might are not aware of this Python. Now, I think it is an opportunity extended by our institution to showcase our institution talent, and as well as you can learn this programming. It will be useful for your career and teach your own students for their development. And it is most accepted by all the major companies, so IT companies. So it will be useful program. I expect a lot of people to participate in this one because our institution is running these type of courses all through the year. And since we are accredited by NB and as well as NAC now, so we are almost into the top level of the engineering institution in and around Mysore. And I wish you good luck for all the participants, since I came to know that a lot of people have already booked from various parts of India, other states also. I wish you wonderful 5 days of faculty development program from MIT Mysore, particularly from Department of MCA. Thank you and congrats to the department for having such a wonderful FDP program. Thank you, one and all.
Thank you, sir.
Thank you very much, sir. Now, I request our Honorable President, Dr. Murli, to address the participants.
Good afternoon to all of you. ಎಲ್ಲರಿಗೂ ಪ್ರೀತಿಪೂರ್ವಕ ನಮಸ್ಕಾರಗಳು. ಡಾಕ್ಟರ್ ನರೇಶ್ ಕುಮಾರ್, ಡಾಕ್ಟರ್ ವಾಸುದೇವ್, ಪ್ರೊಫೆಸರ್ ಮಂಜು, other faculty members of MC department, and my dear participants. I'm very happy to see that MC department is extending their hands in making learning as a simple process. If you really look at national education policy, it says very clearly, it says the resources are to be shared. In fact, they have made this as one of the mandatory component in the national education policy, that resources are to be shared. It is not only knowledge, even the resources like buildings are to be shared. This is what they have indicated in the national education policy. Maybe in the early stage of national education policy, we are just only 5-6 months, we just started implementing national education policy. But nevertheless, MIT has taken a lot of initiatives, especially these aspects. In fact, during the pandemic time, our faculty members have organized many workshops, actually many, it may be 30 to 40 if you really look at the numbers. So these many programs have been organized by our teaching community, and extending hands to other institute also faculty members to join. Similarly, I was looking at the number of courses being attended by our faculty members. It has gone beyond the limits actually. I mean, each one of them would have attended some 10 to 15 like that actually. Then if you really multiply with so many numbers, it has really gone very, very big. And we have seen a lot of research progress in our institute also, with the number of patents being submitted recently. All these things are indicating, even it may be true in your respective institutes also, India is growing with academics. They have changed it actually thanks to pandemic, because our culture of learning itself has been changed. When I heard that actually 5-day faculty development program, I was surprised, how can you bring all these 120 members? But they said it is all online. So therefore, this online has made many, many things easy. Nevertheless, many people skip through online also. So that is also there. Many people simply put on their mobile and keep this and just go away. We can't really avoid. But you try to look at the other part of it actually. Can you imagine 120 people coming to MIT and learning, staying somewhere, having food, accommodation, all these things? Instead of that, at least if 50% of them are very, very serious in learning, our objective is successful implementation. So therefore, a good initiative taken by our faculty members, and that too MCA is never lagging in any of these kind of activities. So congratulations to MCA department and also all faculty members, all participants to try to get maximum out of any kind of level. And I learned that it is free, so therefore it will be another advantage for you actually to pick it up so quickly. So congratulations to all of you and all the best to you for the next 5 days program. Thank you.
Thank you very much, sir. We have come to an end of inaugural function. It's time to thank the august audience. Now I request Dr. Chandrajit M to deliver the vote of thanks.
Greetings to one and all. Honorable Dr. Murli S, President, Maharaja Education Trust. Respected Principal, Professor V.G. Naresh Kumar Sir. Respected Mentor, Dr. T. Vasudev Sir. Our most valued participants, ladies and gentlemen, it's my privilege to propose the vote of thanks on this occasion. Indeed, it's a special day for all of us for being a part of the inaugural function of the 5-day faculty development program organized by the Department of MCA, MIT, Mysore. First and foremost, I would like to thank Dr. Murli S, President, MET, for gracing this event and addressing the best audience. Thank you very much, sir. A big thanks to our respected Principal, Dr. V.G. Naresh Kumar Sir, for supporting and encouraging us to conduct this event. Thank you very much, sir. I'd like to express sincere thanks to our mentor, Dr. T. Vasudev, who is the backbone of our department. Thank you very much, sir. Special thanks to our head HOD and convener of today's FDP, Professor Manjunath B, for his constant motivation. Thank you, sir. We are grateful to the advisory committee and heads of various departments, colleagues for their valuable suggestions and guidance for this workshop. We thank you for being with us all the time. On behalf of the entire organizing team, I thank all the participants from the Pan India and resource persons of the FDP. Finally, I would like to thank all the non-teaching staff for their support. We wholeheartedly thank MIT family for their continuous support and encouragement in conducting this workshop. Thank you very much. I wish you a great learning experience from this FDP. Thank you.
Thank you very much, sir. We shall take a break for 10 minutes and resume for the first session with the same break. Thank you.
तो आवाज ही नहीं आ रहा इसमें।
ಕೇಳಿ ನೀವೇ ಕೇಳಿ
ವಾಸು ಸರ್,
ಡಾಕ್ಟರ್
Yes, I am online.
good afternoon, everyone. I'm Tejaswini Amman, Assistant Professor in the Department of MCA, MIT Mysore. Respected faculty members, welcome to the first session of 5-day FDP on Introduction to Python, organized by Department of MCA, MIT Mysore. I'm here to introduce today's speaker, and it's an honor to introduce and welcome Dr. T. Vasudev sir. So, Dr. T. Vasudev is a passionate teacher serving as a professor in the Department of MCA and Dean of Administration at MIT Mysore. He has a bachelor degree in science and postgraduate diploma in computer programming. He has an PhD. He has hold a PhD in computer science from the University of Mysore. He is an eminent academician with a master's degree to his credit in one of the computer application and another one in computer science and technology. Sir has decades of rich experience in academics, research and research guidance. He has published several research articles in reputed journals and conference proceedings. He has authored a book on HTML, CSS and JavaScript. He has several served as a chairperson of academic bodies in reputed university like VTU, University of Mysore, etc. His area of research interested in mainly digital image processing, especially document image processing. It is indeed a great privilege to have him with us, sir. So thank you so much for accepting our proposal and being a part of our program. Welcome you, sir. So I deliver the lecture on the introduction to Python. Over to you, sir.
Thank you, Madam Tejaswini. Good afternoon to one and all. So it's my pleasure to be with you on this hot day at hot time. I know it is really a tough time to sit in front of screen, especially after a good amount or volume of food. I really understand the difficulty that every audience is facing. So it's basically I understood from the applicants or the candidates who are registered for this workshop is from different backgrounds. So it is a little bit difficult for us to organize the schedule or a program to meet the requirements of such a diversified group of audience. So anyhow, the team has taken a lot of pain to organize and see that major portion of the programming in Python is to be delivered to the aspirants. So with that intention, they have designed this 5-day workshop. So out of this 5-day workshop, so today my session is to give introduction about Python programming, that too elementary part of programming. So I don't specifically say that. I'm just discussing only the elementary or the fundamental things of Python programming, but it includes or it covers the basic foundations that are required for programming, because whatever may be the language that you are using to write the programs, some of the programming fundamentals will remain common in all programming languages. So the major portion of today's discussion in my session will be on the fundamentals of programming. So with this introduction, let me directly get into the topic. So first of all, why do we require to make a change of programming language? So far, many of us writing programs using C, Java, C++, etc., etc. But when people are asking about a new programming language that is coming up in recent days, Python, and it is also gaining popularity. What is the reason behind that? So you have some points to be discussed why Python is getting popularity nowadays when compared to other programming languages. So we shall discuss those one by one. So before I go into the thing, I'll switch over to my presentation mode. Just a minute, please. So let us go with some of the fundamental things that we are supposed to understand in any programming language. So before that, let us see why we are switching over to Python programming nowadays. So first of all, the very first point is that Python is supported with a rich collection of built-in functions. So every programming language do have the support of built-in functions, but compared to the other programming languages, the volume of the built-in functions are very high with respect to the other programming languages. That is one major plus point we notice in Python. So most of the processing we do with the help of these functions, where the programming part becomes much simplified, and the effort that you are putting on writing the programs or implementing becomes much easier when it is compared with other programming languages. So that is one major thing which is making the programmers to have orientation over Python programming. And the next one is, it is a suitable language for developing variety of applications. So when I say variety of applications, it could be a database application or a web application or an image processing application or any sort of networking application. Say it is almost can be used to develop any sort of applications, whereas that flexibility is not so smooth in other programming languages. Say usually we stick on to one particular type of programming language to develop a particular type of applications. But here, in general, we can use this Python programming to develop any sort of applications. That is another point which is making Python to become more popular. And added to this, we have another feature that is there in Python programming languages. It's supporting data structures. So actually we don't use the word data structures there. We use a different name called as storage structures. So Python we specifically do not call as data structures, but though it is actually data structures, we don't use that word data structures directly. Instead of that, it is termed as a different name in Python. It is called as storage structures. So just to give a feel of that, say, suppose if I think of C, we have storage structures or the data structure like basic data, data types and arrays. Then comes pointers, and which is more suitable for your dynamic memory allocation. But here, if you take Python, it is not like that. You will find variety of storage structures available, where each storage structure has its own advantages to be used in the programming. And depending on the application that you are looking for, you can choose one of the most suitable storage structure to write or to develop the program. So your data structure part becomes much simpler when you think of writing programs in Python. So probably those who are very new to Python, they will realize the significance of these storage structures in Python. So especially the non-computer science background students, they prefer Python because of this support of storage structure or data structure. So gradually we'll realize the significance of these storage structures in programming. So as you go through this workshop, you realize the importance or the significance of these storage structures. And the other point is, Python is more user-friendly, having more user-friendly syntax compared to other programming languages. So usually we call C as a crispy language. So every syntax is very rigid, and we need to go with what are the syntaxes that are specified. And sometimes it is very difficult to understand the syntax for a non-programming person. Whereas in Python, it is not like that. It is almost like English-like sentences you will get. And you feel somewhat user-friendly whenever you write instructions using Python. And the other point is, Python is definitely an object-oriented programming language. So you can develop any object-oriented applications using programming, this Python programming, as the programming language itself supports the object-oriented concepts. And the next is, and it is of course most useful point to make this Python popular. That is the possibility of interfacing Python programs with other tools. So whenever you develop an application, if some system is already existing and if you want to add this component to that system, it can be easily interfaced without any difficulty and without any problem. You can have your own module attached to a working system. So these are all the major advantages to see that why Python is becoming more popular when it is compared to the other programming languages. It is just a thing that we need to realize why nowadays people are looking for Python compared to other programming languages. Of course, this is true with non-computer science background people, but as a person from computer science area, I strongly feel that a good programming comes only through languages like C and other our conventional programming languages. Of course, for an advanced learners, this supports your application development much easier compared to other programming languages. So anyhow, this is about the background of why we need to use Python as a programming language nowadays. That is all that I wanted to share with you. Now we shall move on to the very fundamentals of programming. As I told you in the beginning, these fundamentals are common to all programming languages. I really do not know how many of you are already well versed in programming, not necessarily with Python, but with any other programming language if you are already exposed to it. So whatever the things that I am going to cover in this session may be too elementary for you. And for the people who are learning programming for the first time, and if they do not have any exposure to programming, for them it will be definitely useful. And if you have some programming ideas with you, then this of course becomes a supporting thing to learn how programming happens with Python. So anyhow, when we think of programming, the whole programming is based on two things. The entire programming, whatever the program that you develop, ultimately depends or is built only on these two things. Of course, small variations could be noticed as you go with the programs. What are these two basic things that we use always in our programming? One is the data. The very first thing that we use in program is data. And of course, all of you know that we write programs. Here I am not going with the definition of program or what is programming. I hope all of you are quite familiar or having a small, little knowledge about what is a program and what is programming. With that, keeping that in mind, let me go with these things. So we write programs to process the data that we have. And the type of processing that we carry out depends on the type of computation that we need to carry out on the data that we have with us. So normally, if it is a numeric data, we do some computations. If it is other than numeric data, we process it, or say other like text processing for non-numeric data. And if the data is numeric, definitely we carry out some arithmetic operations on that. And ultimately we say that is the processing we want to do. So that means I have data with me. Now I need to do some computations in order to get a result. So this, I assign it to a machine, that is my computer. And my computer does this computation of the data that I have with me based on the instructions that I give to the computer in the form of program to process that data. Say the processing could be as simple as adding two numbers, or it could be a more complex application like complex data processing like finding solution to simultaneous equations. So it all depends on what problem we have considered to solve is the question. Here, whatever may be the problem, the core thing that I need to do is processing of that data. So I have my data. So once I say I have my data, yes, I have to represent that inside the computer. This is my data. So in this form, my data is available. So this is the thing. And of course, if I just focus only on numeric data, so at the most, I have to carry out either addition or subtraction, division, multiplication. These are the basic operations that we need to do it. Now, once I have the data that need to be processed in the computer, I require a place to put my data. So where do I put my data in the computer? Ultimately, it is the memory of the computer. So now, these are the only two things that are required in programming. Fundamental things that are required in programming. One is the data. The other one is the memory location where I have stored the data. So if I am very sure with these things, the rest are all the computations that I want to do. Right? So first we need to understand how this data is represented and how it is put in the memory. So these are the two things that we are supposed to learn before learning any programming language. So one is the data. Usually we call the data as constants. And the locations, memory locations where I store this data is called as variables. Right? So memory locations are the variables which we use to store our data in the computer. Now, when I proceed with these two things, that is data and memory location or the variables, let us try to understand some basic things about these two things. So first, when I say data, normally in Python, it is in any of the four forms. either my data is numeric or it is non-numeric. So when it comes to numeric, my data will be either an integer number or it will be a float number. So numeric data will be either in the integer form or it will be in the float form. So integer is one where it represents a whole number without any fractions. And float number may represent a whole number, but it may have some fractions also. So these are the two different types of numeric values or the data that we come across. So all the whole numbers are termed as integers, and the numbers with decimal, fractions are called as float numbers. Now,
Excuse me, sir. Sorry, sir.
yes.
Sir, I believe that slides are not progressing, sir. We are still in the first.
No. Yes. I am not going with the slides. I am just going with the explanation.
Oh, okay, sir. Okay, sir.
So now, let us go with, because what slides I have goes on with a very detailed explanation. So I am just concising and making it short. So I'm just going with the essentials of programming right now, right? So please, in case if you are uncomfortable anywhere in between, you can interrupt me and then ask for clarifications. Please, if that is required, you can go ahead.
Okay, sir.
Okay, sir.
No, actually, when we consider our data can be any one of these things. My data can be an integer, or my data can be a float, or my data can be a non-numeric data, which is usually we call as a character data or a string data. And the fourth type of data is a Boolean type of data, which has only two values. One is true and the other one is false. Now, when I take a data for processing, my data will be any one of this. So either it will be an integer, or it will be a float, or it can be a string, or ultimately, if it is not all these things, then it can be a Boolean value. Of course, you may find some variation within integer, within float, depending on the programming languages that you use. But in Python, these are the four basic data types of data available. And whatever data that I use for processing will be any one of this, right? Let us try to understand how these are defined one by one. So first is integer. An integer is a signed or unsigned number which consists of only digits, that is 0 through 9. And it is a number without decimal point. And of course, you should not have any special characters within the number. So for example, we have 1, 2, 3, 4 is an unsigned number. So this is definitely an integer. And of course, the next is plus 7, 5, 6. So which is a signed number. Signed number, normally an unsigned number is always assumed to be a positive value. A signed number with plus sign is a positive number. And a number with a minus sign is a negative number. Of course, this is an integer because I don't have any decimal point here. So one point you need to remember here is 1, 2, 3, 4 point. If there is a decimal point, then it cannot be integer. It takes a different form of data that becomes float. So whether you have a fractional part in a number or without fractional part, if the number consists of a decimal point, then it becomes a float number. And of course, this is another number with large number of digits. And especially when it comes to Python, there is no limit for the number of digits for integer. But however, it depends on the versions that you are using, the version of interpreter that you are using. So normally, in general, we say there is no limit for the number of digits in Python for integers. And when it comes to float, again, a float number is a signed or unsigned number, but this should have a decimal point. And no other special characters are permitted. So why I am talking about this, no other special characters means, so usually when we write numbers, we have a practice of separating the numbers for 10,000 position, 10,000 positions, lakhs position. Say to separate that or to indicate that, we use commas in appropriate places. So such commas are called as special characters, and those special characters are not to be used inside your integer number or float number. And the data in float form or the numeric data in float form will be always available in double precision form in Python. Say if you look for C, we will find two types of floats. Either it will be a float in single precision, or it will be a double precision number, which we call as double, right? So there the number of decimal places will be double in case of double precision. So here in Python, the number of decimal places is up to 16 digits. So whenever you carry out a numerical computation for float data, the computation is done up to 16 decimal places. So that much of accuracy you can have in Python. Whereas in C, we have both a single precision as well as double precision. So depending on your choice, you can go for either single precision float number or double precision float number. Whereas in Python, you don't have that selection. All float numbers are in double precision form only. And this float numbers can also be expressed in the exponential form, that is 10 to the power of value. Say for example, here the last line, if you notice, 22.33 E12, which is equivalent to 22.33 into 10 to the power of 12. So these are the numbers in exponential form are represented like this. I think those who are already familiar in programming, it is almost same in all programming languages. And the next type of data is a character data or a string data. It is nothing but it is basically non-numeric data. When I have one or more characters enclosed within a pair of either single quotes or double quotes, represents a character string or a character data or a string data. Say in my discussion, I am not focusing much on this string data because you have a complete session on strings. So there you will be learning more about this string. So here, how to represent a string data is all the question that comes here. So if I have a non-numeric data, I can have that data enclosed between either with a single quotes or I can use double quotes also. So in Python, it is allowed to use both single quotes as well as double quotes, but both should be, say if I'm using left quote as single, right quote should be single quote only. If I'm using left quote as double quotes, right quote also should be double quotes. One I cannot have single quote, the other I cannot have double quote. And Python uses ASCII format to represent alpha characters in programming. So in other words, the coding format that is used in Python is ASCII. And these are the two standard functions that are available. This gives the order of the ASCII, and the other one gives me the character value of that. So the ASCII value of A is 65. The odd gives the encoded value for that particular character, and CHR gives me the actual character equivalent of that ASCII value. So reversible functions. So RDA gives me 65, whereas character 65 gives me the alphabet A, uppercase alphabet A. Next, the last type of data that we have is Boolean. It's a logic. It's called as a logical type, or it's a logical value. It is having only two values. First one is, one value is true, the other value is false. And usually 0 represents false and non-zero represents true. Now, before going to literals, let me move on to the other thing that we need to understand in programming. The other thing that we want to understand in programming is the variables. So far, the data that we have discussed is termed as constant, or is termed as constant. So it can be an integer constant, or it can be a float constant, or it can be a string constant, or it can be a Boolean constant. So these are the basic type of data that we can store inside the computer. Now, when I store my data, I require a memory location. And all of you know that computer has got a voluminous amount of memory. And if I have put my data somewhere in the memory, I should remember where exactly I have stored my data, or in which location I have stored my data. So for that, programming supports an access of memory location by a name. So whenever I use a memory location, or whenever a memory location is allocated for my program to store a data, it is called as a variable. And each variable, I have the liberty to give a name to it. So the moment I give a name for a memory location, a mapping will happen between the name and the memory location. So I need not remember the memory location. I remember only, if I remember only the name of that memory location, that is sufficient. So when I give the names for the memory locations, I have to follow certain rules. So the basic, the fundamental rules that we have to follow to give the names of the variables or these things. Say, a variable name should always start with an alphabet and can have combinations of digits, alphabets, as well as underscore. No other special characters except underscore is permitted. And the name cannot be a key or a reserved word. And the number of characters for a name is unlimited. You can have as big as the variable name you would like to have. The following are the examples of variable names. So I can give one memory location as the length, another location name as area, then side 1 x55. So here circumference I have given a sufficient lengthy name, and then triangle area where I have used underscore. So these are some of the valid examples of valid variable names, which is invalid. Suppose if a variable name starts with a digit, then it becomes invalid. And suppose if any special character other than this underscore is there, then it is again invalid. Now, with these two things, let us try to understand how we can go ahead with programming in Python. So I am just explained you what are the different types of data and what are variables. So with these two things, let us try to have a small hands-on practice on the interpreter directly. So I'll move on to the interpreter. So now on my machine I have a Python version of 3.8.1. So any Python version above 3.2 is almost, you don't find much variations in that. Suppose if your Python version is 3 and below 3, so you will find a lot of variations from version 2 to version 3.2 onwards. So I think nowadays almost all people are using 3.2 and above versions. So except some advanced feature, we are not finding much variations in these versions. Now, we have understood, so once you load the Python, you get an interpreter ID like this. Here, let me see which are all the type of data that we are trying to understand. Say, suppose if I have a data 345. So this is according to me an integer, right? 345 is an integer because it is an unsigned number, no decimal point, no other special characters. So definitely it is an integer type of data. Now this number I want to store in some memory location. So that memory location is termed as a variable in programming. Suppose if I say x equals, so 15. So what does this mean? So here, this is a data which is in numeric form and of course integer, and I have an equal sign, and here I have a variable name. This is a name that I have given to one of the memory location. That means the data of 15 is stored in a memory location X. So I repeat, for the people who are not familiar with programming, the data of 15 is assigned into the memory location which is labeled as X. So now one of the memory location in my computer is labeled as X. In that location, 15 is stored. Now, whenever I use this memory location by the name X, it always shows me 15. So now I have stored my data in one of the variable. That means a memory location, and the name of that memory location is X. Now, what is available in X? I want to see. So it says it is 15. So the content of this memory location is 15. So in other words, if I observe this statement, I slightly read it out in a different way. In programming perception, we say that 15 is assigned into the variable X. That's how we speak. 15, the data 15 or the number 15 is assigned to the variable X. So this equal sign is called as an assignment operator, which assigns a data on right hand side to the variable on left hand side. And the syntax is always this way. Left side you should have only the variable name. Right side you can have another expression, another data, or it can be another variable also. Now I'll use another statement. Y is equal to, what is the data in Y? X I have 15, stored 15, and Y in Y I have stored 10. The content of X is 15, the content of Y is 10. Now I'll say Z is equal to X plus Y. So what happens here? It will not look into the left hand side first. First it does the calculation on right hand side. So it takes the data in X. When I use a variable name, some data should be available there. So it goes to that location. What is the data you have in X? It is 15. And it takes the data from Y. The data from in Y is 10. So 15 plus 10, that is the computation is happening. So what is the data I have now as a result? It is 25. Where it has to be stored? It has to be stored in another variable Z. Right? So the moment I put this, the operation is done. Some processing has happened. So I have taken a data which is available in one memory location. I have taken another data in another memory location. I have done some operation. The result what I am getting is putting in another location. So now if I say Z here, see I got the result. Okay, basically X is a memory location, Y is a memory location, Z is a memory location. Since I have written these statements, I know what is X, what is Y, what is Z. Suppose if a person who has not done is not familiar with what operation has done, if they display the content of Z, if they access the memory location Z, they get this value. Now, in assignment statement, left side, it should be always a single variable name. Right side, you can have assignment, it can be a constant, or it can be an expression, or it can be another variable. So, for example, what is the content of X? Content of X is Z, 15, and content of Z is 25. Now, if I say X equals Z, so what will happen with that? It will not, like mathematics, I will not say that X value is equal to Z. It's not like that. Here, the value that is stored in this location Z is assigned to the variable X, which is on left hand side. Now, what is the content of Z? It is 25. When I put this data into X, already I have some data in X. What is that data? 15. Now it overwrites that 15 and new data is stored in that location. Now just see what is the content of X. Content of X is 25. Earlier it was 15. Now it is 25. And of course the content of Z will remain same. So now, sir, earlier you said Z is equal to X plus Y. Now X plus X has value changed. So that doesn't mean the operation that you had carried out already got changed. So earlier when I said x plus y, it was 15 plus 10, 25. Now I assigned a value 25 to x, so I lost my earlier value. Now no change will happen to z. So because I have changed 15 to 25 here, 25 plus 10, 35, now the present value of z is 35. That will not happen. It will happen only to that variable and not to any other variable. And the other operations that we usually go ahead with this assignment is the arithmetic operations or minus, that is subtraction, multiplication, division, and then mod operation. So let us discuss these things one by one. Before that, let me tell you one more thing. Say programming allows you to increment or decrement by specific values with respect to the value that is already stored. Now in y I have the data 10. So I want to increment the value of y by unit 1. So suppose if I say y is equal to y plus 1. So what is y? I'll see. Earlier y was 10, now y is 11. So what this statement does? So mathematically this is a meaningless statement. This condition cannot be true at all. Even y is 0, 0 equals 1, it will not happen. So this is not a mathematical statement. This is a programming statement where the content of the present content of y is taken here. What is the present content of y? 10 plus 1 is 11. This result is assigned back to y. So now y is having 11 because earlier it was 10. 10 plus 1 is now 11. The content of y now has become 11. So like this, you can go on incrementing the content of a memory location by whatever the amount of value that you want to increment through, and with the other way, the decrement also we can carry out. So suppose if I say y is equal to y minus 1 or y is equal to y minus 2. So now the present value of y is what? 11. 11 minus 2 is 9. So let me see what is the value of y. It is 9 only. So we can carry out some of the basic arithmetic operations through the operators. Say the one we have discussed is the addition operator, that is the plus sign. Suppose if I say 5 plus 8, I get the addition of two numbers. So here in place of data, I can use variables. If I use variables, what happens? It takes the data which is stored in that memory location. Here also it takes the data that is stored in that memory location. So ultimately, at the end, this binary operation is carried out. So 5 is one data, 8 is another data. These two are arithmetically added. So that is 13. I got the result. And suppose if I say 8 minus 3, so that is 5. So minus is the operator that is used to perform arithmetic subtraction. And of course, multiplication, 5 into multiplication is done through star. So 5 into 3 is 13. Next, we have division. So Python supports two types of division. One is the integer division. The other one is regular division. Suppose if I say 5 divided by 2, slash is the operator that is used to perform division. So 5 divided by 2, I get 2.5, which performs the normal division. And there is an integer division also, which is done by double slash. So whenever I use double slash, it performs integer division. And you get the result, only the quotient is obtained. The remainder, I lose it, right? So integer division always gives me the quotient of the division. Whereas the mod operator gives me the remainder of the integer division. So mod operator is percentage. Now if I say 5 mod 2, this is remainder is 1. So 5 double slash 2 gives me quotient, and 5 mod 2 gives me the remainder of the division. And this integer, this mod operator I cannot use on float data. If I use on float data, it does the perfect division. Say, suppose if I say 5.0, it's a float number. If I use now 2, so I get 1.0, right? That is a reminder, no, here. Where is that? It converts to integer and then gives. So normally if I use some fractions, say 4, so this 5.0. So now, a reminder, it gives in some, normally we use the mod operators for only integer values and we don't try these reminders for the float values. So whenever you use the mod operator, see that your operands will be always in the integer form, then you can expect the correct result. Otherwise, your numerical computations will be as usual only, right? Now, apart from this, Python provides you one more special operator as the arithmetic operator, that is power operator. So in C and Java, we have a built-in function to carry out the power operator. So whenever I want to find x to the power of n, so in C we write power of x comma n. This is how we write of course, power of x comma n, this is how we write in C, that is x raised to the power of n. Even in Python, this power operator is available, power function is available. So let us come to that discussion a bit later. Now, to carry out these operations, I can directly use the operators. So there is one power operator which is indicated by 2 double stars. So the first becomes the base, first operand becomes the base, and the second operand becomes the power. So suppose if I say 5, this is 5 to the power of 2. So 5 to the power of 2 is 25. So this is an additional operator that we notice Python when compared to C and Java. And of course, in C and Java, it is not available. We have to use a built-in function. Whereas in Python, this power operator is available and we can directly use whenever we want to find power for some base value. Now, when I use these operators, when I carry out our mathematical operations, we are so much exposed by looking at the expression itself. We say, so this I have to compute first. Then this has to be divided by this, and this has to be multiplied with this. By looking at the expression, we are experienced to tell this is how it has to be carried out. Whereas in programming, it will not happen. So it will follow certain precedences. We call it as precedences. So based on that precedences, the arithmetic evaluation happens, or the evaluation of the expressions happen. And this precedence is nothing but the priority or the preference through which the arithmetic operators are evaluated. So there are 3 levels of precedences available for arithmetic operators. The first precedence goes for the power operator. So in an expression, it looks for the power operator first, it evaluates that. Then it looks for the multiplication, division, and the mod operation. That is the second precedence. And the least precedence is given for plus and minus. So for example, I have 3 plus 4 into 2. Now if you look at this example here, so I have a plus operator and I have a multiplication, addition operator and multiplication operator. So out of these two, I have precedence for star compared to plus. So first computer always evaluates this multiplication. So 4 into 2 is 8. So then it performs the remaining operator, evaluation of the remaining operator. So this side it is 3 plus 8 is 11. That's what you have. Now, suppose if I have with equal precedences, say if I write 3 into 4 into 2. Now, it will not do 4 into 2 first and then the result is multiplied with 3. So when I find the operators with the same precedence, it is connected with another feature called as associativity. So associativity is the direction through which the arithmetic operators are considered for evaluation. Now, when I have this operators of similar precedence, so it always uses from left to right for star, slash and percentage. Now I have 9 divided by 3 into 4 mod 5. Let us see what happens. Sorry. 9 divided by 3 into 4 mod 5. Okay. 9 divided, say this is slash is there, multiplication is there, and mod operations are there. So all are with equal precedence. So they are with the precedence level 2. Precedence level 1 is double star. Precedence level 2 is, it can be single slash or double slash, star, and then mod. It is from left to right. Left to right, first it does the division. 9 divided by 3, that is 3, into 4. 3 into 4 is 12. 12 mod 5. So the remainder of 12 divided by 5 is 2. So I get the remainder of, the total result of this expression as 2. Now computer will not find multiply 3 into 4 first, then it does 3 into 4 is 12, 12 mod 5 is 2, then 9 divided by 2, answer is 4.5. So that way it will not do. So it will look from left to right. So whichever operator comes first in the same precedence will be evaluated first for these operators. Similarly for plus and minus also it is from left to right. But the associativity for double star is from right to left. It is from right to left. Say, 2 to the power of 3 to the power of 2. Say, for example, 2 to the power of 3 to the power of 2. Now look here. 2 to the power of 3, here also I have an operator, here also I have an operator, both are with the same precedence. Now it is not from left to right. For power operator, the associativity is from right to left and not from left to right. So first 3 to the power of 2 is done. 3 to the power of 2 is 8 and 2 to the power of 8 is the done later stage. So 2 to the power of 8 is 512. By chance if this happens from left to right, say 2 to the power of 3 is 8. 8 to the power of 2 is 64. My answer is not 64, it is 512 because the associativity is from right to left. So first 3 to the power of 8 is computed, 3 to the power of 2 is computed, then 2 is raised to the power of 8, so which results me in 512. This thing we have not observed in our C and Java because we don't have this operator. That is the reason why we are not giving much importance for associativity in C. Say we always say that the evaluation happens from left to right because we don't have this power operator. So power operator only has the associativity from right to left. So because of that, instead of getting 64, I am getting the answer 512. And this point you have to keep in mind always when you use this power operator in your expressions. And most of the time, what I have noticed with my students is this. So when I say the associativity for 2 2 double star is from right to left, the students will misunderstand my statement like this. Say they try to evaluate the expression from right to left. Say they say it is 2 to the power of 3, right? And then they go for, say it is 2 to the power of 3 is 8, 8 to the power of 2 is that way. They say this, they try to take this as the base. No, here, when I say right to left, say this is a binary operator. This becomes the base, this is the power. So 3 to the power of 2 is 8, sorry, 3 to the power of 2 is 9, is it not? 3 to the power of 2 is 9, and then 2 to the power of 9 is 5 and 2. Sorry, I told it is 2 to the power of 8 is 512, it is 2 to the power of 9. 2 to the power of 9 is 512 because 2 to the power of 10 is double of this, 1024. So now, with this, let us try to go with the other features of the other operations with especially Boolean. Now, when I say Boolean, my result will be either, my value will be either true or false. And this, where do we normally get these results? So these results we get with respect to some relational operators. So I carry out a relational operation between two data. The result of the relation, what I try to establish, will be either a true relation or it will be a false relation. So suppose if I say 5 greater than 2. So this greater is a relational operator. So I'm trying to establish a relation between two values, 5 and 2. So 5 greater than 2 is a true result. I mean a true result, and it is true also. The result of this relational operation is a logical value. Now similarly, suppose if I say 5 less than 2, I get false. So like that I have various relational operators. One is 5 greater than or equal to 2, and then 5 less than or equal to 2. So greater than, less than, greater than or equal, less than or equals, 5 equals 2. So notice that it is double equals, it's not single equal. Single equals we have already used. So we have used that single equals in assignment as assignment operator. So we don't have scope to use that single equal sign here. So if I want to have a relational expression or relational operation of equal, it is double equals. So similarly 5 not equal, not is indicated with exclamation. So 5 not equal to 2 is true. So these are all the various relational operations that we have. And these relational operators does not have any precedence. All operators are of the equal precedence, but associativity is available. The associativity for relational operator is always from left to right. And the next type of operators that we are supposed to learn is the logical operators. So 3 logical operators are available. One is the OR, the next one is and the last one is NOT. So these operators, logical operators, work on logical values, right? So operands should be logical values. NOT is an unary operator. It works only on a single operand, and it complements or negates the given value. So for example, not true. Not true gives me false, and similarly not false gives me true. It negates or the complements whatever the value that I have as a logical result. And we have other 2 operators. One is OR and the other one is AND. So all of you know how OR and AND works. So for OR, when both the values are false, the result is false. In rest of the case, it is true. And in case of AND, if any one value is false, the result is false. But when both the values are true, the result will be true. So for example, I have true and true. I get the result as true. So suppose if I have true and false, and false is false. So when you have false or false, result is false. So in case of R, if one value is true, the result will be true. Or eliminated or truncated. So that's what happens in case of C and Java. Whereas here it is not like that. It directly stores, the type of the variable is of the type of the data it is storing. So I can use one variable to store at one instance of time, I can store one type of data. At another instance of time, I can store some other type of data. So like that, I can keep on changing the type of the data also in a variable. But one thing you need to remember, that is the moment you put a new data into a variable, the previous data that was stored is lost. Next is when I assign my data, I can assign multiple values to multiple variables. So for example, A I want to assign 5 and for B I want to assign 8. So normally what we do, we say A equals 5 and B equals 8. Now what is the content of A? 8 and the content of 5 and the content of B is 8. Now in a single assignment statement, I can assign those values. Instead of going with these two statements, I can use a single statement. I say A comma B comma C. How many values I have to assign? 3 values I have to assign. So I'll say 1, 2, 3. So 1 is assigned to A, 2 is assigned to B, and 3 is assigned to C. So this I can also write as A equals 1, B equals 2, and C equals 3. Now these multiple values can be assigned to multiple variables with a single assignment statement. So that is what you have. Now you see A is 1, B is 2, and C is 3. So what is the advantage of this? So the advantage of this multiple value assignment has multiple folds. The first one, all of us are familiar with the logic that is required to interchange the contents of two variables. So most of us use a third variable to interchange the contents of two variables. So suppose I have 5 in A and 8 in B. How I have to interchange? So I take a temporary variable, to that one of the data I put, and for A I put the data from B, and for B I put the data from T. Now what is the content of A? It is 8. And the content of B is 5. It got interchanged. Earlier, I had assigned 5 to A and 8 to B. Now, these three statements have interchanged the values. So now I have 8 in A and 5 in B, which got interchanged. Now, this logic I can build with the assignment statement itself. Now, suppose if I say A comma B equals B comma A. Now, don't think it will do swapping inside itself. So it takes the data from B. What is the data in B? 5, right? And it takes the data from A. What is the data in A? It is 8. So first data is 5, second data is 8. So first data is assigned to first variable. So this 5 is, B is, that is 5 is assigned to A and 8 is assigned to B. So with this, I'll get back my values. What is A? 5 and B is 8. So initially what I had put in A and B, that I changed with this logic. I brought those values back with this multiple assignment. So multiple assignments help us to carry out these type of operations also. So apart from this, I have some built-in functions. Straight away I can use with the values. Say I have a set of data. Let us assume that I have a set of data. So these things you will learn more in detail when you move on to the different storage structures. So I'll consider some data here. Here I have a set of data. I should call it a set of data. So X is representing a set of data. The first data is 1, second data is 4, third data is 6, and fourth data is 3.3, and the fifth data is 5.1. So when I have a set of data, I can carry out some operations on such set of data. One of them is known as len. So this len gives me the number of items that you have in that set. So 5 elements are there. 1, 2, 3, 4, 5 elements are there. Next is I can find the minimum value in that set. So the minimum value is 1, and the max value also I can find. So the maximum value is 6 out of this, and I can also find the sum. Sum of x is 19.4. Now, these are some of the operations that you can use on set of values. But one point you need to remember, so len you can use on heterogeneous. Say here, I have all numeric data. So when I have a set of data, it can be heterogeneous also. Some may be numbers, some may be strings, and some may be logical. So heterogeneous type of data items can also be here. So what happens here, when I say len, it gives me number of elements. Min, I'll have a problem because so I cannot equate one numeric data with a non-numeric data. And similarly, I cannot equate a non-numeric data into a Boolean data. So carefully you have to use these functions with homogeneous type of data. Otherwise, you cannot expect a proper result. Most of the time it gives error. But sometimes you may not able to get the correct result also. Say if I put some operator, some function for non-numeric data, it has no meaning. So when you use it, you have to carefully use these functions. So directly when I have a set of data, I can use this. Say to understand the importance of this, let us consider a problem. A very simple problem I take up. I want to find, say all of us as a teachers, we know usually we give 3 tests to the students and we take the average of the best 2 tests. That's what the usual practices that we have in our system. Say suppose if I want to have if I want to build a program for that, how simple it could be done in programming, so that we shall see. So here I'll not use directly, I'm not writing any programs using file. So directly I use some statements. Let us say marks 1 is integer of the input. So this function I'm supposed to write. No, let me go to program because so that may not give you a proper idea. So 2 things I'll explain and then I go to a program. So next is how to provide input for a data. So one of the way that I can use to put the data is assignment. So I always assign a constant value to a variable. Now I should make it as generic. So each time I should not give the same value. I have to keep on changing the values. So for that, I have to use a runtime input operation I need to do. So when I run my program, I should provide the required input. So for that, you have a function or a statement called as input function or input statement through which you can provide a data during the execution of the program. And if the data is to be provided from the keyboard, then this input statement has to be used. So what is the syntax? Say normally we use the word a variable name here. Variable equals input, right? So what is the data in variable? 5. Just look the difference. I gave the data as 5, but the data that is stored is in string format because it is enclosed between quotes. So whatever that input that you give will be in the string format from the input statement. Now, if I have to type my data or input my data in the numeric form, I have to convert the type of the data through type conversion. So sometimes my data will be integer or sometimes it will be float. Now, depending on what type of data you want to input, so that you can give x is equal to int to suppose close one. Now just cx. So my input was 5 and the data stored is also numeric 5. Whereas here it was string 5. If I simply use input, it will be storing in string format. Now whatever string format that you have, that is converted to integer and that is stored in x. Similarly, now if I say y float input y is 2.5. If I simply say y is equal to input, if I give 2.5, say y, if I say it in string format. So after the input operation, I have to convert the type of the input to the respective type, and this is called as type conversion. I can convert the string to input, integer, or I can convert whatever the input that I have given to float format. So when I give my input, sometimes I'll be not knowing what to do. So in that case, I have to give some prompts or I have to make my program user interactive or some sort of interface has to be provided. Say for that I make the operation like this, int now it is asking enter A. That means what value you are supposed to type. So it is given here. Now if I say 5, so that will be converted to integer and it is stored in A. So suppose if I say A 5. Now this is the message that should appear before the input. That means it will tell what the user is supposed to do. Enter A means, and your cursor will be waiting here blinking, and you are expected to type a value for A. And what value you type, that will be stored in the memory location A. So this is for inputting the data. Now, after the computation, I get a result. After the computation, I get a result, and that result has to be displayed. Normally, the result will be inside the variable memory of the computer, but it has to be given back to the user or to see what is the result of the computation or what is the outcome of the processing should be specified, should be known. So for that one, I have to get the result obtained to the user, and this is achieved through a print statement. So print statement displays the content of a variable to the user on the display screen. Input takes data from the keyboard, whereas print gives the required output or the value stored in memory locations or variables to the user on the display screen. Suppose if I say print So the content of y is 2.5, I got it. Say, if I say print x comma y comma a. So I have to print the content, the data that is stored in this location. Here I am putting a data into a memory location. Here I am displaying the content of those memory locations. So a value is 5, y value is 2.5 and a value is 5. Say if only these three are given, say probably the recipient, whoever receives this output, may not understand what are these exactly. So to make it more meaningful, we provide some information about these data along with the actual output. Now, suppose if I change my print functions this way, x equals x. So this is a message that is appearing along with my data. X is the actual data, but what is this data is explained or described here. Next, the data I am printing is y. So that message I should get, and then I say y. And similarly, lastly, I have the data to be printed a, and it is a. So the actual outputs are x, y, a, and these are the messages that I have used to explain what are these data, or to make it clarity or clear what are these data. Say it doesn't mean it will check whether this x is same. No, in order to make it meaningful, I have this message. In order to make this output meaningful, I have this message. You can type whatever you want. Say you can say this is length, and you can say height, and this, and say width. So your computer will not take all those things. So now length is 5, height is 2.5, width is 5. So just to make what these actual outputs are, or to provide some meaning to this output, so we can provide some messages along with the actual output. Now with this background, we shall try to write a simple program so that how we can use all these things in our applications or in our program, so that we shall see. Now whatever that we have discussed so far, I'll give it in the file, take it to the form of a program. So let me go to file here. I open a new file. Say comments in Python is done by hash. So you know each programming language has its own representation for comments. So you have for C /* and ending with */. And for C++, you have double slash, right? Now, this is program, or I can say a sample program. So what this program does, it takes marks of 3 tests, finds the average of the best 2 tests. So that's all it has to do. Say test 1 marks, I call it as T1, int, input, enter, test 1, marks, T2, similarly it is also integer, T3, right? So when I run the program, this will allow you to type, input first test marks, this is for second test marks, this is for third test marks. Now, I have to find the sum of the best 2 tests. So that means I have to remove the least test with the least marks So what I'll do is I'll find small as in of T1, T2. So this function we have seen minimum of this data set. So out of these three tests, I don't know which is the smallest one. So the smallest one will be identified and it will be stored in a variable small. So I have test 1 marks, test 2 marks, test 3 marks, and I have found which is the smallest of these things. That's how. Now, what is sum of the best two? Sum of the best two is you have T1 plus T2 plus T3 minus small. I don't know which one out of these three, which one is small. This small gets cancelled with the smallest of this T1, T2, 3. So next, I have average given by sum divided by 2. So print T1 equals So I have done all the required calculations. So I have to find the average of the best two tests. Let us see. This is the program. I save it. I give a name. Sample 1. Now I run the program. So before that it is asking for save. So it is asking enter test 1 marks. I'll say 15. Enter to set 18 and our test is 19. So you have T1 15, T2 18 and T3 19, average is 18.5. So the best two is what? 18 plus 19. So it is 18.5, the average of the best two tests. Say suppose if all the three tests are seen, then one of the three tests will be taken as small. It will find the average of the rest best two like that also. So you can just see the difference. Now, this is 15, this is 15, this is 15. So average is again 15. So like this, you can have the computational part of your program with this. So usually any program will have the required inputs, and this is the place where we get the output, and this is the processing part. So depending on the complexity of the problem, the program also becomes more complex or simple. So if it is a straightforward formula, your program will be a simple straightforward one. Otherwise, it will be a more complex one, and the computation also will be complex. And one of the major disadvantage that we notice in case of Python is, so this input statement allows you to enter only one data at a time. So I cannot input more than one data with a single input statement. So this is a limitation that we have. But however, we can overcome this limitation with the string handling operations. So probably when you learn string operations, there with little modifications, it is possible for us to input more than single value from a single input statement. It can be 2, 3. It all depends on how many number of values you have to enter through a single input statement. Say it is okay. Now I have only 3 inputs. Suppose if I have 6 or 7 inputs, I have to keep on writing this 6 times, right? So that becomes laborious for a program writer to repeat the same set of statements. So of course, a modification, or you can overcome that limitation with some modifications in programming, so which you will be learning gradually in your successive sessions. So now, when I carry out the processing of numerical data, my numerical data always may not be directly used in our computation. I need to calculate something else along with the actual processing. So for example, to find some result, some intermediate calculations also I am supposed to do it. So finding my final result itself is a big task. In addition to that, I need to carry out some intermediate calculations also. So this increases my effort in writing the programs. So in order to ease out this difficulty, or this what you call as efforts, to reduce the efforts in writing the programs, almost all programming languages are supported with what are called as built-in functions, right? So these built-in functions help us to make when writing programs or coding becomes simpler and easier to directly get our solutions without putting much programming effort while writing the programs. So one of such built-in functions normally that we use is our mathematical functions. So every mathematical function itself is a computation. So for example, I have to calculate factorial. I have to find factorial of 5. So factorial of 5 is not a simple calculation. I need to do multiplication so many times. Similarly, I want to find the square root of a value. Say finding square root of a value requires a set of operations. So first of all, I am forced to write programs. In addition to that, I need to write programs for all these intermediate computations also. So this increases my effort in writing the programs. So to reduce that, already some built-in functions are provided along with your compiler or interpreter, whatever it is. Now, my job is to use those built-in functions directly in my program so that my programming effort becomes simplified or much with less effort. We will find plenty of such built-in functions, but these built-in functions are categorized depending on the applications or the nature of those results. So all the built-in functions, so in turn, basically these built-in functions are subprograms. So subprograms are designed or developed to do a specific type of computation. So these subprograms are already available, right? So we call them as subprograms because they are not the main programs which do not directly do the computation. So to carry out computations, we use those ready-made subprograms to avoid our effort of writing more lines in programs. So already a unit is there. That unit we use directly in our program. It is like a component. We use that component directly and see that our writing program becomes simplified. Now, when I want to do a computation like, say, this one, I want to find the cos, sine series, sine value of an x using series. So that is a big equation. So I write a equation, series, Taylor series expression to find the sine value. So sine of x is nothing but x minus x to the power of 3 divided by 3 factorial plus x to the power of 5 divided by 5 factorial minus x to the power of 7 divided by 7 factorial, etc., etc. It goes. Now, each term is a computation there. And within that, I have to find factorial every time. First time I have to find factorial of 1, next time I have to find 3, next I have to find the factorial of 5. Say, finding factorial itself will become a subproblem for me. So for that, your programming languages support ready-made subprograms for that. Whenever I want factorial, I can use that subprogram. Whenever I want to find square root, I can use that subprogram. Similarly, whenever I want to calculate sine value of an x, I can use that subprogram. So these subprograms are collections, right? So I collect all the subprograms related to nature of the computations and we store them as libraries. And these libraries in Python are called as modules, right? So all the ready-made subprograms related to some mathematical operations are called as math functions. And these math functions are stored in a module called as math. So if I have to use any of these functions, ready-made functions or built-in functions in my program, I have to import that. Because they are external to my program, if I import, they become a part of my program and I can use them in my program. Suppose if I go to C or C++, we use hash include. So we are including those libraries into our programs. If you go to Java, import statement is there. Even Python we have to import. So there is a module called as math. What is a module? Module is nothing but collection of built-in functions. Now I have a module called as math. So this module I have to import. So once I import, I can use these functions in my program and I can ease out the way of writing programs to solve the problem. Now let us discuss about those things. Right? Say, I want to find factorial of 5. Say, I know factorial of 5 is 5 into 4 into 3 into 2 into 1. I think it is 120. So 120 is the answer. 5 factorial is okay. Next, I have to find 10 factorial. So I need to do calculation. This I don't want to do. So I want to use the built-in function, the ready-made subprogram that is available to get the result. So instead of writing my own program, I use a ready-made subprogram, that's all. Say factorial is a function. Factorial of 5, if I write like this, I get an error. Yes? Any? Yes. Hello. 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 Is there any disturbance?
Yes, sir, we are checking.
Shall I proceed or what?
One second, sir. We'll just
Okay, sir.
Okay. Now, this factorial is a function, ready-made subprogram. And of course, this is a built-in function. Right now, I cannot use this because this is not a part of my program. So if I try to use this factorial, so I'll get an error, right? So factorial is not defined. It is defined somewhere else. Where it is defined in a module called as math. To use that, I should first import it. Import math. So now this module is imported into my machine. Now I can use those mathematical functions in my program. But even now I cannot directly use the name as such. It's not possible because when I have to use a function belonging to a module, I should specify the module name also along with the function name. So math dot factorial I need to use of 5. Now you see I got 120. Say here, there are other versions, some slight variations are there with importing. So I can avoid this writing math every time when I want to call the mathematical functions. There is a method, but now I am not discussing that. You keep in mind that whenever you want to use a function name from a module, the module name also has to be specified. That at this point of time you keep in your mind. Now, I want to find square root of some value. If I simply say square root of 25, I'll not get, because square root is not there. I've imported already math, but I cannot use it. So I have to use that along with the name of the method, or sorry, module. So now if I say sqrt of 25, I get square root of 25 as 5. Next is, I want to find the sine value of x. Say, let us say I want to find sine 90. All of us, if the question is asked to us, what is sine 90? We say it is 1, right? So now let us see what answer we get here. Sine 90, I am getting 0.89 something. So here, when you look this expression, you will get surprised. What is this? Sine 90, I should get 1, but I am getting as 0.89 something. It's correct answer, because all your trigonometric functions will work for radians and not for degrees. So this 90 degrees I have used, but the method or the function sine has taken this 90 as radians. So for 90 radians, sine value is this much. Suppose if I want to find the sine value for 90 degrees, I have to convert this degrees to radians explicitly. So math dot sine of, what is the conversion factor? 3.14 divided by 80 pi by 180, is it not? So that is 3.14 divided by 180. So now what I am doing, this 90 degrees I am converting into radians. So pi radians is equal to, that's what I am using the conversion factor. So now it is 0.99999, approximately equal to 1. Whereas this I cannot say it is approximately equal to 1. So actually I should get 1, my value is very close to 1, right? So this is how we are supposed to find the trigonometric values. Whenever your trigonometric functions are to be used, be careful that the argument should be in radians and should not be in degrees. In case if it is in degrees, you are supposed to convert, and it is your responsibility to convert it into radians. And similarly, I have other functions also, like math dot log of say 30. So this log 30 is for this is natural logarithm I have got. So this is natural logarithm of 30. Suppose if I want for base 10, then it is log 10 of 30. So I get 1.4 something. Say here, there is a variation, variant forms of log are available. So one is math.log. If I don't specify anything, it gives me natural logarithm. Suppose if I say, so the first is the value to which I have to find log. Second parameter specifies the base to which I have to find the log. Now it is log 10. So what is log 10 of 30? 1.477. I should get the same answer. So yes, 1.477 I am getting. So this is my natural logarithm. So math. So math E is to the base E. Natural logarithm is to the base E. So 3.4011. Here also I have 3.4011. So this is for natural logarithm. Similarly, I can find a logarithm to base 2 to base 8. So whatever the log value that you are supposed to find for a specific base, you can do it. Say two constants are available in math. One is math.py. I get 3.1415, etc., etc. See, it computes up to 16 decimal places, right? Similarly, you have E value, math.e. I get 2.71828, etc. is the value of E. And if I have to use these constants, this math I am supposed to write along with that name, right? And as you told, 1 divided by 3, I should get 0.33333 up to 16 decimal places I should get. So this is how I get the computation, right? So these are some of the basic things which remain almost common in all programming languages. So I think we have pulled out sufficient time for this session. So I am very much sure that I am trying to put more things in a given amount of time, which is really not advisable for the people who are learning programming for the first time or do not have much exposure to programming for them. It is difficult, I do understand. But for the rest of the people who are well aware with the programming concepts, for them, I don't think whatever the things that I have explained is not very new to them. So with this, I think I just try to conclude as time is also coming to end. So thank you for all your patient listening. In case if you have any queries, please share it with the organizers. I'll try to get back through them to give whatever the clarifications that you require. So I thank you one and all. So thanks for the organizers to giving me an opportunity to engage this session. So once again, thanks to one and all.
Thank you very much, sir, for spending your valuable time and sharing your knowledge. Now the floor is open for question and answer. So participants, if you have any queries, please drop your questions in the chat box. Any queries? Or else you can unmute yourself and you can ask the question. Participants, if you have any queries, please.
No, if not directly, if you have any specific queries, you can send it through mail. We'll be happy to clarify those things.
Okay. I think we come to an answer. So there is no any queries in the chat box. So I think okay. Thank you, sir, and participants. So kindly fill the attendance and feedback form shared in the Google Meet and WhatsApp group. Thank you all. See you tomorrow at 2 p.m. Thank you, Mudita.